Hello students, in continuation with the chapter alcohol, we will discuss the reactions involving cleavage of breaking up of carbon-oxygen bond. Generally, the alcohols readily undergo these type of reactions. Alcohols, they undergo the reactions involving cleavage, CLEAVAG, cleavage of carbon oxygen bond. But if you consider phenols, generally phenols are having, they doesn't undergo, under normal condition they does not undergo the reaction involving CO bond because they contain partial or double bond character between carbon and oxygen. Okay, they contain partial double bond, hence under normal conditions they does not readily undergo these type of reactions. Now let us see reaction with hydrogen halides. Reaction with hydrogen halides. Reaction with hydrogen halides. Reaction with hydrogen halides. Generally HX, hydrogen halide. When alcohols react with hydrogen halides, alkyl halides are formed. When alcohols, ROH represents alcohols, reacts with hydrogen halide, eliminate a molecule of water like this, reacts with hydrogen halide, you are going to get RX plus H2O. This is alkyl halide. The order of reactivity of different alcohols for the reaction with given hydrogen halide is in the order tertiary, secondary, primary. Okay, the order of reactivity is tertiary. They undergo immediate reaction with hydrogen, given hydrogen halide to form alkyl halide, then comes secondary, then comes primary. And we can treat this particular reaction as the distinguishing test between primary, secondary as well as tertiary alcohols. Okay, as the order of reactivity is different for different alcohols, and we can consider this particular reaction as the distinguishing test between primary, secondary and tertiary. Okay, as the alcohol reacts with hydrogen halide, you are going to get alkyl halide. These are insoluble in water, hence precipitate, hence they appear in the form of precipitate, and that particular reaction is called as lUCAS test. By using lUCAS test, we can distinguish primary, secondary as well as tertiary alcohols. Now let us see what is lUCAS test. lUCAS test, this is an important test which can be used to distinguish primary, secondary as well as tertiary alcohols. The alkyl halides or the alcohols when treated with the lUCAS reagent, alcohols reacts with lUCAS reagent, that is mixture of anhydrous ZnCl2 and concentrated HCl. This is known as lUCAS reagent. When alcohols, any type of alcohol is treated with the lUCAS reagent, that is mixture of concentrated HCl and anhydrous zinc chloride, if it gives immediate turbidity, immediate precipitate, immediate turbidity or precipitate that represents tertiary alcohol. Alcohol gives immediate precipitate. If precipitate appears after 5 minutes, precipitate appears after 5 minutes, then that alcohol is secondary. Secondary alcohol gives precipitate after 5 minutes. Then if turbidity appears only on heating, or precipitate appears only on heating, then that is primary alcohol. In this way we can distinguish primary, secondary and tertiary alcohols. This test is called as lUCAS test. Okay, alcohols when treated with lUCAS reagent, that is mixture of anhydrous zinc chloride and concentrated HCl, if it gives immediate precipitate, then we can treat that one as tertiary alcohol. If you are going to get precipitate after 5 minutes, that is secondary alcohol. If precipitate appears only on heating, that is primary alcohol. First immediate precipitate tertiary, precipitate after 5 minutes secondary, precipitate appears only on heating, that is primary alcohols. In this way we can distinguish primary, secondary and tertiary alcohols by using lUCAS test. Now we'll discuss the reaction of alcohols with the phosphorus trihalide. General formula is px3. Alcohols reacts with ROH. Alcohols reacts with phosphorus trihalide px3. You are going to get alkyl halides Rx plus H3PO3. 3 molecules of alcohol reacts with the phosphorus trihalide. You are going to get the corresponding alkyl halide. Well, let us discuss one example. Ethyl alcohol C2H5OH or CH3CH2OH. Example, this is general reaction. Example, CH3CH2OH, ethyl alcohol reacts with the phosphorus tribromide. Already we have discussed this type of reaction in haloalkane chapter. You are going to get 3 molecules of CH3 CH2Cl plus H3PO3. This is Br. It is not Cl, it is Br. So it is ethyl bromide. You are going to get ethyl bromide. Alcohols also reacts with, okay, we can take it as a note. Alcohols also reacts with thionyl chloride. We have discussed this type of reaction also in haloalkanes and haloarenes. Alcohols reacts with thionyl chloride. That is SOCl2. Alcohols reacts with thionyl chloride to form corresponding alkyl halides or haloalkanes. You are going to get haloalkanes also. For example, CH3 CCH3 CH3OH. This is tertiary butyl alcohol. Or every time, or we'll consider one more. We'll take different example. CH2, CH3. 2-methyl 2-butanol or 2-methyl but 2-methyl butanol. 2-methyl butanol reacts with thionyl chloride SOCl2. We are going to get CH3, CH3, Cl, CH2, CH3 plus SO2 plus HCl plus HCl. This is 2-chloro-2-methyl butane. 2-chloro-2-methyl 2-chloro-2-methyl 1 2 3 for butane. 2-chloro-2-methyl butane. This is parent chain, contains 4 carbon atoms. So 2-chloro-2-methyl butane. This is IUPAC name of the alkyl halide formed. Okay, this is the reaction of alcohol with thionyl chloride. Now we'll discuss dehydration reactions of alcohols. When alcohols are heated with concentrated sulfuric acid, we'll write that reaction R CHOH CH3. When alcohols heated with concentrated sulfuric acid, concentrated H2SO4, heated with concentrated sulfuric acid at 443 Kelvin temperature. Alcohols heated with concentrated sulfuric acid at 443 Kelvin temperature. Dehydration takes place, forming alkene. Removal of water molecules takes place. You're going to get an alkene plus H2O. This reaction is called as dehydration reaction. Molecule of water is eliminated, so this reaction is called as dehydration reaction. Dehydration reaction because it loses a molecule of water. Example, when ethyl alcohol is heated with, when ethyl alcohol CH2H CH2OH, this is ethyl alcohol. Ethyl alcohol is heated with concentrated sulfuric acid at 443 Kelvin. You are going to get ethene. A molecule of water is lost. You can eliminate molecule of water here. Molecule of water is lost, or we can show like this, and this bonded pair of electrons, they move like this. This is ethene plus a molecule of water. This is the example of dehydration reaction. We'll consider one more example. 1-butanol CH3 CH2 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 1 2 3 4 CH2 OH or butanol or 1-butanol in the presence of concentrated H2SO4 at 443 Kelvin. We are going to get CH3 CH2 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 no, CH2 CH double bond CH2 plus H2O. You are going to get one butene or bute 1ene. This is the dehydration reaction of alcohol. During dehydrogenation reaction, we can use some other dehydrating agents, such as we can use phosphoric acid H3PO4, which acts as dehydrating agent, or we can use anhydrous zinc chloride. You can use anhydrous ZnCl2, or you can use alumina also. Alumina formula is Al2O3. We can use these reagents as dehydrating agents. The rate of dehydration for different alcohol is in the order tertiary, secondary and primary. Means this tertiary and secondary, they undergo easily dehydration, so we can maintain milder condition. We can maintain milder condition for dehydration reaction as far as secondary as well as tertiary alcohols are concerned. Now let us see the examples for this. Isopropyl alcohol CH3 CHOH CH3 propanol. Here we require 85% phosphoric acid. Sulfuric acid is not required. You can use 85% phosphoric acid. 85% phosphoric acid. Then temperature is also less 440 Kelvin. At 440 Kelvin, we are going to get an alkene CH3 CH double bond CH2 plus a molecule of what this is prop 1ene. Now let us this is secondary alcohol. Now let us consider tertiary alcohol. CH3 OH. This is tertiary butyl alcohol, or this is also called as 2-methyl propanol. 2-methyl propanol or tertiary butyl alcohol. Tertiary butyl alcohol. This is tertiary alcohol. Here we can use 20% phosphoric acid, milder oxidizing agent. 20% H3PO4, and temperature is also less, 358 Kelvin temperature. 358 Kelvin temperature, we are going to get an alkene CH3C double bond CH2 CH3 2-methyl propanene 2-methyl prop 1ene plus H2O. Here in case of secondary and tertiary alcohols, we require milder conditions. In secondary alcohols, we need 85% phosphoric acid at 440 Kelvin. But in case of tertiary alcohol, we need 20% phosphoric acid. Even temperature is also means at milder conditions, secondary and tertiary alcohols undergo dehydration reaction. Now let us discuss mechanism of dehydration of alcohols. Consider the dehydration of ethyl alcohol. Ethyl alcohol, already we have discussed this reaction. Ethyl alcohol, when heated with sulfuric acid at 443 Kelvin, ethene is formed. As a molecule of water is eliminated, eliminated from ethyl alcohol, you are going to get an alkene, that is ethene. Now let us see the mechanism part. What is mechanism? Stepwise explanation of a chemical reaction is known as mechanism. Step 1, protonation of alcohol. Protonation of alcohol. Concentrated sulfuric acid protonates ethyl alcohol to form ethyl oxonium ion. Sulfuric acid protonates CH3 CH2OH. This is ethyl alcohol plus H plus. It contains pair of electrons plus H plus. So you are going to get protonated alcohol CH3 CH2 OH2 plus. This is known as protonated alcohol. Protonated alcohol or ethyl oxonium ion. Ethyl oxonium ion. Then in step 2, the oxonium ion formed loses a stable molecule of water to form a carbocation, and this is the slowest step which determines the rate of the reaction. We'll write that. Second step is formation of carbocation. The protonated alcohol, that is ethyl oxonium ion, loses a stable molecule of water, H2O, to form a stable carbocation, CH3 CH3 CH2, and this is slow step in the mechanism, that is rate determining step. This is rate determining step. This step is second step is rate determining step. And this is carbocation. This is carbocation. In step 3, elimination of a proton. Step 3, elimination of a proton. Elimination of proton. Okay, first step is protonation of alcohol. Sulfuric acid protonates ethyl alcohol to form protonated alcohol, that is ethyl oxonium ion. Ethyl oxonium ion. Then step 2, formation of carbocation. Ethyl oxonium ion formed loses a stable molecule of water. To form a carbocation. Then in the third step, elimination of proton. The carbocation formed loses a proton to form the final product ethene. CH3 CH2 plus. This is carbocation, loses a molecule of water. Loses a proton Yes, you can. Yes, carbocation loses a proton plus H plus to form an alkene called ethene. You are going to get ethene and alkene. This is mechanism of mechanism of dehydration of alcohol. Mechanism of dehydration of alcohol. Okay, first, whenever mechanism is asked, you have to write all these things. Consider the dehydration of ethyl alcohol. Ethyl alcohol, in the presence of sulfuric acid at 443 Kelvin, ethene is formed. Mechanism. In the first step, the first step is protonation of alcohol. Sulfuric acid protonates ethyl alcohol in this case to form a protonated alcohol. Protonated alcohol, and this is the fast reaction, and you are going to get ethyl alcohol by gets protonated from protonated alcohol, that is called as ethyl oxonium ion. In the second step, formation of carbocation. The ethyl oxonium ion formed loses a molecule of water, stable molecule of water, to form a carbocation. Then in the last step, elimination of a proton. Carbocation formed loses a proton to form a stable final product, that is ethene. This is mechanism of dehydration of alcohol. This is the mechanism of dehydration of, in this case I have taken example, ethyl alcohol. Mechanism of dehydration of ethyl alcohol. Let us discuss some commercially important alcohols. First, methyl alcohol, that is methanol. It is colorless liquid, looks just like water, colorless liquid with a boiling point 337 Kelvin. Boiling point 337 Kelvin. Boiling point 337 Kelvin. It is also called as, this is called as, methyl alcohol is called as wood spirit. It's called as wood spirit, which is obtained by the destructive distillation of food. This is obtained by destructive distillation of food. Destructive distillation of food, hence it is called as wood spirit. Now let us see its preparation of methyl alcohol. Preparation of methyl alcohol. When carbon monoxide is mixed with hydrogen, when carbon monoxide is mixed with hydrogen and passed over heated zinc oxide catalyst, and chromium oxide as a promoter, Cr2O3. Zinc oxide catalyst and Cr2, the chromium oxide, acts as promoter, and temperature 573 to 673 Kelvin. 573 to 673 Kelvin, under pressure 200 to 300 atmospheric pressure. You are going to get methyl alcohol. This is also called as methanol. Carbon monoxide is mixed with hydrogen in the presence of zinc oxide catalyst, Cr2O3, as a promoter at temperature 573 to 673 Kelvin, under pressure 2 to 300 atmosphere. You are going to get methyl alcohol. This is preparation of methyl alcohol starting from carbon monoxide as well as hydrogen. Now let us see the uses of methyl alcohol. It is used as solvent in paints and varnishes. Used as solvent in paint and varnishes. It is used in the preparation of. It is used in the preparation of formaldehyde. Used in the preparation of formaldehyde. It means this methyl alcohol is subject to oxidation, controlled oxidation. You are going to get formaldehyde. Number 3, preparation of denatured alcohol. It is used in the preparation of denatured alcohol. Denatured alcohol, used in the preparation of denatured alcohol. Here the rectified spirit is mixed with small amount of methyl alcohol, that is called as methylated spirit, and it is unfit for drinking purpose, as methyl alcohol in small concentration, methyl alcohol, methanol or methyl alcohol, already we have discussed this, methyl alcohol in small concentration, causes blindness, and it is taken in a large quantity, that leads to death. These are some of the uses of methyl alcohol. Now we'll discuss the preparation and uses of ethyl alcohol or ethanol. Ethanol is also colorless liquid. It is also a colorless liquid with the boiling point 351 Kelvin. Boiling point of 351 Kelvin. Now let us discuss its preparation. Ethyl alcohol is commercially obtained by fermentation of cane sugar. Here sugar is obtained by the fermentation of cane sugar. Here during this fermentation C12H22O11, okay, sucrose, okay, during fermentation yeast is added that provides two enzymes, invertase as well as zymase. Enzyme invertase converts or brings hydrolysis of sucrose. Your enzyme invertase brings the hydrolysis of sucrose. You are going to get glucose and fructose, C6H12O6. This is fructose, C6H12O6. This is glucose and this is fructose. Then enzyme zymase converts C6H12O6. Enzyme zymase converts glucose or fructose into ethyl alcohol, 2C2H5OH, ethyl alcohol and carbon dioxide, Here the ethyl alcohol formed is having percentage of 14%. Okay, you are going to get 14% of ethanol. If this concentration exceeds, if the concentration of ethyl alcohol exceeds, that stops the enzymatic action of invertase as well as zymase. Hence the concentration of ethyl alcohol should not increase, and its fermentation is carried out in anaerobic condition. fermentation carried out under an aerobic condition. If anaerobic condition means in the absence of air. If air is introduced in the this fermentation process, then ethyl alcohol undergoes oxidation to form acetic acid, vinegar. Hence, the taste of alcohol is lost. Taste of alcohol is lost. Hence, it is carried out in anaerobic condition, and during this process, carbon dioxide is liberated, which helps to maintain anaerobic condition. Carbon dioxide prevents oxidation of ethyl alcohol with oxygen present in the atmosphere. This is about the preparation of ethyl alcohol. Now let us see uses of ethyl alcohol. It is used as solvent. It is used as solvent in paints, solvent in paints, oils and fats. It is used as solvent in paints, oils as well as fats. Number 2, it is used in the preparation of alcoholic beverages. Alcoholic beverages. Number 3, it is used in the manufacture of compounds like used in the manufacture of acids, esters, haloalkanes, etc. Haloalkanes, etc. Number 4, it is used in the preparation of power alcohol. It is used in the preparation of power alcohol. It is used in the preparation of power alcohol, which is a mixture of 20% ethyl alcohol, 20% ethanol, 20% ethanol, and 80% gasoline. 80% gasoline, which is used as a fuel for internal combustion engines. Internal combustion engines. ENGINES. Internal combustion. These are the uses of ethyl alcohol. Now let us see about rectified spirit. Alcohol obtained by the fermentation. It contains 14% ethyl alcohol, 14% ethanol is distilled to get. Is subjected to distillation. You are going to get 95% ethanol. 95% ethanol or ethyl alcohol. That is known as rectified spirit. This is known as rectified spirit. As rectified spirit forms azeotropic mixture. Rectified spirit forms azeotropic mixture, means constant boiling mixture. We cannot separate water present in the ethyl alcohol. Now let us see how absolute alcohol or 100% ethyl alcohol is manufactured from rectified spirit. Manufacture of absolute alcohol from rectified spirit. Manufacture of absolute alcohol from rectified spirit. Here rectified spirit is mixed with spirit. Rectified spirit is mixed with required quantity of benzene, mixed with required quantity of benzene. A rectified spirit is mixed with required quantity of benzene, and this mixture is subjected to distillation. This mixture is subjected to distillation at 65 degrees centigrade. At 65 degrees centigrade, a ternary mixture containing ternary mixture containing water, benzene and alcohol. Water, benzene and alcohol, because here rectified spirit contains 95% ethyl alcohol and the rest water, means two components are here. This is a third component. Such type of mixtures are called as ternary mixtures. This rectified spirit is mixed with the required quantity of benzene and subject to distillation at 65 degrees centigrade. Ternary mixture containing water, benzene and alcohol distills. Okay, it distills till water is removed. Till water is removed from the reaction mixture. Then the boiling point of this mixture, rises up to 68 degrees centigrade. Benzene is removed. Benzene gets distilled. Benzene is removed. Then this mixture is again subjected to distillation. This mixture is subjected to distillation at 78.4 degrees centigrade. 78.4 degrees centigrade, you are going to get 100% ethanol, that is known as absolute alcohol. Okay, first rectified spirit is mixed with the required quantity of benzene. In this mixture subjected to distillation at 65 degrees centigrade, a ternary mixture containing water, benzene and alcohol distills till water is removed. Then the temperature increases to 60 degrees centigrade, where benzene is removed, or you are going to get distillate which contains benzene. Then the temperature of the mixture is increased or rises to 78.4 degrees centigrade till then the 100% ethyl or absolute alcohol gets distilled. It is purest form of alcohol. In the laboratory, the absolute alcohol can be formed as follows. First, this rectified spirit is treated with quicklime. Rectified spirit that is 95% ethyl alcohol is mixed with quicklime, calcium oxide, that absorbs water, and the liquid is distilled. The resultant liquid is subjected to distillation, is distilled. Then last traces of water are removed by treating with calcium metal. Treating with calcium metal. This is how we can prepare absolute alcohol. Absolute alcohols are in the laboratory. First, a small amount of water is removed by adding quicklime, and the last traces of water removed by treating with calcium metal. This is the preparation of absolute alcohol in the laboratory.